All right, so welcome to part 2 of Remote Learning 9, and what we're going to focus on in the next 15 or 20 minutes is preparing quadratic functions for intercepts form. So in the first part, then I went over what intercepts form looks like. So here it is in a formal way. So we have a function that is a parabola, and this is its a value, but it is now written as the product of two binomials. And in order to make them sort of random or arbitrary binomials, I'm going to use this slick little process of calling one of them x minus p and one of them x minus q. Now, what we saw was that the x-intercepts were at p, now remember, not at negative p, it was at p 0 and q 0. So it seems a little strange, but we saw that that was a result of setting the function equal to 0 and going after the height 0 and using the zero product rule, where you ended up having to add p to each side and add q to each side. So I'm not going to rewind that part. But let's see. A lot of students like to call this the opposite game, where you don't use minus p, but you use positive p. Okay, so those are the x-intercepts. And then the vertex's x-coordinate was found by averaging those x-intercept values. So there's that in its strange format. And the y-coordinate of the vertex is found by plugging that value that you find in to the function. So this is going to get really weird, but this is what you would have to do, knowing that p and q were numbers. These would all just be numbers at this point. But I might as well show you sort of the abstract nature of the process. Okay, so just a quick little example over here then of finding the x-intercepts and vertex of a particular one. And again, this is just a repeat of what happened in part 1. Okay, so I'll make quick work of this. The x-intercepts are going to be at 2, 0 and negative 6, 0. The vertex's x-coordinate is going to be found by averaging those values, and that is going to wind up to be negative 2. And the y-coordinate is going to be found by then putting that negative 2 in for x in the f function. And in this problem, it looks like I get negative 80 for the y part. So now I know the vertex is at negative 2, negative 80. Okay, so that's a recap. Now then, this one was in intercept form, so that's not what we're after. In part 2 here, we're going to be preparing quadratic functions for intercept form, so let's get into that. Now then, my directions are going to be for you to find the x-intercepts, the vertex, and graph. So we didn't do any graphing in part 1, but now we're going to extend it to graphing. And these functions that I give you are not going to look like the ones in part 1. They're going to need to be prepared for the format called intercept form. Okay, so this looks like standard form, and I could do a lot with this. Like I could say it opens up and its pattern is the normal 1, 1, 2, 4, 3, 9 pattern. And I can find its the vertex's x coordinate by using negative b over 2a. But I'm not going to do any of that. That's not what I'm after. I'm after the x-intercepts, the vertex, and the graph. Okay, so while I can think about those things, and it might help me decide if I'm right later on, okay, what I want to do instead is prepare this for the format where it is in this format, the intercepts form. Okay, this is a skill we already know how to do. This is essentially factoring, right? We want it to be written as a product, and we don't have it written as a product right now. We have it written as a sum and difference. So we need to factor it. So with a leading coefficient of 1, we're back to our old friend think of two numbers. And we spent a whole chapter factoring. And think of two numbers that multiply to negative 12, but add up to positive 1. That is a 1 right here. And then there we have it. Okay, and the a value is 1. So I'm going to just rewrite it with it not being there. But sometimes there is a number out there, so I just wanted to have you thinking about that. Not in this case, though. So that's the same problem. That's the same function f, but now it's in its factored form, which is to say it's in its intercepts form, so I can proceed. Now, in the first part, I made you do things like set the function equal to 0 and break it apart. But I think now we can speed up the process because we've seen it a bunch of times. And we would know that the x-intercept is at negative 4, 0, and 3, 0. Okay, so nice. That's the first part. What about the vertex? Well, the vertex's x-coordinate is found by averaging those. So, okay, I'll put that in and average them. And, okay, I get a fraction. So some of you are panicking, but fractions are numbers, so you do need to be able to deal with them, including all of this crazy fraction work where we drop in negative a half. Okay, so let's see. I'll do the work here. Negative times the negative is positive. That's going to be 1/4 minus a half minus 12 over 1. I'm going to go for a common denominator of 4. This one needs to be multiplied by 2. This one needs to be multiplied by 4. And let's see. So that's 2/4. And this one is 48/4. And that turns out to be, what is that? 1 minus 2 is negative 1. That's negative 49/4. Okay, so let's get that. Let's see, negative 4 goes in there 12 times with 1 left over. All right, so I've got the vertex is negative 1/2 and negative 12 1/4. And let's graph it. Okay, so building a nice graph. Knowing that I got to go down to negative 12, I think I'm going to count by 2's. That's going to make life a little bit easier. So before I forget, let's just make sure I put in 2's everywhere. Going to count by 2's. Okay, so let's see. I've got a x-intercept of negative 4, 0, and 3, 0. And I've got smack dab in the middle of that negative a half. This is negative 1, keep in mind, so negative a half is right about there. And then I go down 2, 4, 6, 8, 10, 12, and 1/4. So yeah, I'll just make that quarter upright like that. Okay, so I don't need that little marker. Parabola. Whew. All right, this is the best I can do. This is going to be a tricky one. Okay, that's what I need you to do. Let's do another one. Oh, let's recap like the main idea. Here is the main idea. Factoring. That's what that skill is. It is back. We're not done factoring. Okay, we got time for one more before I send you out there to practice a few. So let's go with this new one, which I'm going to call G. And same direction. So let's see. Find the x-intercepts, the vertex, and graph. All right, and this one is going to be negative 2x squared minus 10x minus 12. Okay, it's in standard form. That's no good to us. Well, I mean it is, but not for the directions here, not when it says x-intercepts. Okay, so then I have to factor it. I got to turn it in to one that looks like the product of some binomials. Factoring. If you recall, you're supposed to go through this whole list of things, list of ways of factoring. And if you go through the list in the right order, life gets a lot easier for you. And the first thing on the list is old school factoring. I'm taking out a negative 2. They all have a negative 2, leaving x squared minus 5x plus 6. You can distribute the negative 2 back in there to check. Okay, well, all right, fine. I got a negative 2 out there. And now I can think of two numbers factor this guy. And it factors into x minus 2, x minus 3. And, all right, so it looks like I already know the x-intercepts. And they are 2, 0 on the opposite game, and 3, 0. Well, all right, so then the vertex's x-coordinate is average those, and when you average them, you get 2.5, which I'm going to leave as a fraction, because I'm noticing more and more need to review fractions. So cleverly designed problems to be helpful and annoying. Sorry about that. Okay, the vertex's y-coordinate is found by plugging 5/2 in. Okay, so you could plug it back in up here, or you could plug it back in here. You get to decide which one you like. Okay, so because they're the same, right? That's the whole idea, that we have factored. Let's get that again. Factored, right? That's our old friend factoring. That's how you turn standard form into intercept form. All right, so I'm gonna go into this second one because I think it's gonna be a little bit easier. It's gonna be a negative 2, and then I have, you know what? I think it probably is worth going to decimals on this one, just because I see it being a little bit nicer for us. Okay, so let's see. What is that? That is 0.5. And this one is negative 0.5. And, well, that's a negative times a negative, so now I'm not even going to think about negatives anymore as positive. 2 times 1/2 is 1. And 1 times 1/2 is 1/2. Okay, so I'm going with that as 1/2. Vertex 2.5, comma 0.5. Or if you want to be a friend of fractions, 5/2, comma 1/2. X-intercepts, check, check, we got it. Vertex, check, check, we got it. Graph, we don't have it. Let's go get it. And then that's a wrap. Ooh, let's go with red on this one. 2, 0, 3, 0. Ooh, they're really close together. All right, now 2.5 makes sense because it's right down in between 2 and 3. So there's 2.5, and then it's up a half. So there's that one. I never did put a scale on here, so I should probably do that. That's 1, 1, -1, -1. So yeah, 2, 3, those are the x-intercepts. 2.5 half, that's the vertex. And it goes down, but I knew it went down the whole time because it was negative way up here in the beginning. All right, I also know it goes down in a fairly steep fashion. Okay, so I don't need you to do anything other than plot the 3 points and do your best to draw a parabola at this point. But the way you do that is you got to remember how to factor. All right, so I said I would be a little bit quicker on this second half, so I'm getting close to being 20 minutes in. Let me see if I can pick a wise one more because I do have a few minutes. I'm squeezing in one more. Okay. Let's go with black. All right, we're just going to find the x-intercepts on this one. So this one is going to be function h, because I called the other ones f and g, and it's going to look kind of weird. So there it is. I'm not putting the constant. It just has those two pieces. But it is not written as the product, hint, hint, of two binomials. So I definitely need to factor this. So let's see. The first factoring thing that we always do is see if we can do any old school factoring. And they have an x in common. So you get to take that out. Okay, so now you're like, well, that's all the factoring I can do. It doesn't really look like this, but you can force that, right? So you could write plus or minus 0 here. It wouldn't matter. And then you can do what we've done and go get the intercepts. And the intercepts would be 0, 0 from this one, and 6, 0 from that one. So that is the origin, but the origin is one of the x-intercepts. Okay, so I won't go on to find the vertex graph on this one, but I wanted to show you one that I thought might be a little problematic because that's kind of a tricky little extension of the conversation. Okay, so then here comes assignment part 2. Okay, here you go. Here are the 5 problems for part 2. Please do follow the examples that I laid out in remote learning part 2. Make beautiful graphs, please, the best you can, and label things up. It all comes down to factoring. Okay, thank you.